communism, so I can do what I want. All right. So here's our sum and difference formula. Sorry for just starting the video now, and I already just went through that. These are going to be on our Wednesday formula little quiz. That's very similar to Friday's last week quiz. I have to give those quizzes tomorrow. Anyone that hasn't taken it, I don't know what I'm going to do. We can't wait for you. The absence people, I can't do it anymore. You are thwarting and holding back what I can do with everyone that is here. As far as learning from those little quizzes and what adjustments I have to make. So once I have to pass it back, it's like canceled. I don't know what else I can do. It's frustrating. Okay, so anyway, those will be on and then this is the usage. This would be Thursday, along with some other proving some identities kind of thing. Malik, you're not sleeping back there, are you? Holy smokes! No way, not going to allow. Okay, so now here's what we got to do. This is when something's got to come out of your mind here. All right, first of all, I have cosine. So guess what I'm going to try to do? I'm going to try to make this happen. I'm going to try to make that angle measure that I have some or difference. That is an angle measure or angle measures that work great for trig from chapter 3. And I told you, Chapter 4, we get a break from 30, 60, 45s, except for deriving the graphs. And now when we get to Chapter 5, they're coming back, and boy, they're coming back with a vengeance. So somebody think, I had this happen last hour, just give me two angles when added together. The two angles that when added together, the two angles are a 60, a 45, or a 30. I basically just gave you the angle measures, but that when added together equal 105, and the two angle measures are perfect angles from chapter 3 that I can find trig in exact format with radicals. Anyone? Raise your hand, please. Yes, Alexis. I literally said them. All right. You can rewrite this as cosine of 60 plus 45. I mean, I couldn't get around it. Those are our exacts. Our exacts are a 30, a 45, or a 60, and then any of the ones that are in any other quadrants. But to be honest, you can get real fancy with this stuff. You know what else equals 105? 135 minus 30. You can put 135 minus 30 in there. What's 135? What kind of angle measure is that? Ends in a 5, so it's probably 45 in quadrant what? 2. So I probably should have spent a moment to remind you of those, but I just tried to pound those in your head in that other chapter. We don't do that yet, but I will stamp. So let me take those and stamp those. There we go. We're going to keep this rolling. Probably after a break, guys. Okay, so anyway, there's a whole bunch of options. All right, so now this is why I don't think it's that big of a deal. Okay, so first of all, look at your sheet. I'm not going to keep going up to there. What is cosine? And let me get somebody, because I can see this is a Monday. So here we go. We're going to do this. Yay. I love it. Let's get our numbers. All right, now again, this is about chapter 3. This is about remembering your chapter 3 stuff. Ooh, they're terrified. Do they know their 45s, 30s, and 60s? At least the calculator's giving you time to think. Nice. Enter. Student number 1, nice. Mitchell, first of all, looking at your formula sheet, what is cosine sum? Is it cosine or sine? Which one is it? Now, Mitchell, I see you staring at it. Which one is it? Cosine sine or cosine to start off? And then what's the sign in between? Opposite. So Mitchell's staring at his sheet right now. Mitchell, if you do your homework tonight, put that sheet away. Put it off to the side. Try to guess. Try to get yourself ready for Wednesday's quiz. And then look at it and say that you're right. Okay, after that, okay? So make sure you do that. I know that was the first question, though. Then, of course, it's sine. And then this is why I can get the exact answer for this. Exact means in radicals. This is what engineers need to do. I'm not going to be an engineer. How do you know? But at least it's a process, and it isn't hard. It's not beyond your ability. Okay, then we're going to get the ball rolling. No, I'm not going to do this. What's cosine of 60? Do you know? You're pretty good at this stuff. Oh, sine of 30 is a half. So cosine of 60 can't be a half. So what's cosine of 60? I know that's weird how I just went through all that. Now root 3 over 2. It's what? Okay, we're going to draw it. Here's 60. Here's root 3. Here's 30. Where's he getting these from? Chapter 1, 2, and 3. Blah! All right? 1 and then 2. This drives me nuts. Still, students that can't do this. Ah! I'm sorry, you just saw that on the video. All right, what's the answer? Oh no, what's cosine of 60? 1/2. All right, 1/2. All right, and then what's cosine of 45? I refuse to draw that triangle. That one we wrote a million times. All right, let's move on. Let's see if they're paying attention here after punching the thing there. 12. Who's 12? Who's 12? Is that you? Yeah. Wait, 8, 9, 10, 11, 12. Yes. Evan, what is now sine of 60? That's the root 3 over 2, and we can look at that over there. The minus is built into the formula there. And then what's sine of 45? It is, and everyone should know that. Did you know about the half too? You're good with this stuff, right? Do you remember that? I shouldn't have to do a whole page of this again. Actually, we started off the chapter with that little sheet that you were supposed to do, and if you didn't do that for homework, again, you're severely and totally behind. But trying to remind you of those 30s, 45s, and 60s before we opened the chapter. So we already did it. All right, already did it. All right, so this is root 2 over 4 minus root 6 over 4, not root 5. Not root 5. Root 3 times root 2 is root 3 times root 2. 3 times 2. And then you can write this as or root 2 minus root 6 over 4. One common denominator, one answer. That's usually how the final answer is written. Fine. Where'd they get the root 2 over 2? If you still have to draw a triangle, 45 is 1, 1, root 2. Where'd you get that triangle from? Actually, I lied. Chapter 2 and Chapter 3, not Chapter 1. That's where the 45, 45, 90s and 30, 60, 90s came from. That's why it's catastrophic, the consistent and constant not doing your homework. It will always come back to bite you. All right, here we go next. If 2 people go on that one, we'll have 2 people go on this one. 6. The directions are still, Alexis, find the exact value. But this is a reverse analysis. Right off the bat, I'm already reversing the process. Look at your formula sheet. Which one does this mirror? Does this mirror a sine or a cosine formula? This is a sine. Now, again, you won't have that in front of you. Well, you might. We might have that in front of you on the actual application part. So fine. Realistically, on Thursday's test, if this question comes up, you have that in front of you. Oh, that looks like sine. Which one is sine, minus or plus? It's the minus. And then who am I subtracting that mirrors the formula when I stick the parts in the right spot? Like what angle minus what angle? Look at your formula sheet. Look at A, look at B, and then tell me who A and B is, who they're taking the place of. 40 minus 160. So that's number 1. Number 2, just getting people going. Mitchell, the calculator loves you. Where's negative 120 fall? What quadrant? Fine. If you were in calculus, you know you're in quadrant 3. What is the reference angle? No, what is the reference angle? The answer would be 30, 45, or 60. That's what we did in chapter 3. We had to figure out what kind of angle it was and then what quadrant, and you already found the quadrant. What? It's a 60. So actually, it's funny you got picked again. What is sine of 60, first of all? You literally just got to ask this question. Sine of 60, actually you got to ask cosine of 60, which is a half, so sine of 60 is root 3 over 2. And then what, is it positive or negative? That's what I was going to say next. ASTC. So a calculus teacher, you're not going to be here next year unless you flunk out or something, and then you got to stay one more senior, 5th year. You're not doing that. Everyone's fine. But there used to be a junior class, and then calculus, this is how they start calculus out with these questions. With sine of negative 120, and you got to be super fast in getting that answer. So it is negative root 3 over 2. And if anyone's looking at this like this is what's going on, you lost a whole chapter, you lost the whole 2 chapters. We did this 30, 60, 90 analysis in chapter 2 and in chapter 3. The escape, calculus teacher would be mad if he had to draw that this is a 60 here. Root 3, 1, 2, that's another, and then the calculus teacher would be ticked that I'm even still writing those side measures. All right? I was supposed to do something else with memorizing fractional things and all that other stuff. I always like this as a fallback. Memorizing one thing and using it over and over and over and over and over again. But again, we have different things going on with different students, and some memorize and some just will not, and it becomes a real problem for those that cannot. All right, but see what happened there. Was this a reverse, and then it ended up being an easier question? It turned into a chapter 2 question after using the formula. Okay, next thing with radians. People hate radians because it starts with an F. R, A. Anyone? Fractions. They just can't do fractions. And then I did this in the other hour, and I just put your mind in the right spot here. What are exact values? What are angle measures that are in exact values? What are the denominators? Over what? Over what or over what? 3, 2, 1, go. 3, 4, and what? 6. So it has to be either an over 3, an over 4, or an over 6. By the way, what's an over 6? What's the reference angle? 30. What's an over 4? 45. What's an over 3? 60. So basically, I have to get a sum or a product where I get these denominators. All right? And this is why 12 is a popular denominator. Pi over 12, just 1 pi over 12, I'm going to tell you what it's going to be. It's going to be subtraction. That's how you get so small. That's how you get an over 12. 1 pi over 12. So what minus what equals 1 pi over 12? First of all, get them in terms of over 12. Can someone think of some fractions that this blank pi over 12 minus blank pi over 12 equals 1 pi over 12? And the 2 blanks reduce to a denominator of any of these 3. I don't know if you can understand that high-level question. You go ahead, Evan. Now, you did not. You already reduced those. What's pi over 3? What over 12? So you already reduced. You went 2 steps on me. You are not. What are you not? You are not fractionally challenged. You are not fractionally challenged. All right? And then what'd you say? You said pi over 3 minus pi over 4, which is what? And then he went ahead and reduced. Boom shakalaka. This is why 12 is a popular thing, because 12 goes with 6, 4, and 3, like as far as reduction is concerned. Now, everyone in this room better not cry, because you should know that 4 pi minus 3 pi is 1 pi over 12. All right? And then the next thing, since we're a little worried about you here, we'll go ahead and reduce. This is tan of pi over 3 minus minus pi over 4. Love it. Okay, so now look at your formula sheets. Boom shakalaka. Student number 19, absent. Student number 17, absent. I hope this keeps happening. Student number 6, blame these 2 that don't come to school. All right? Ivo. All right. What's the formula say? What happens next for tan of a difference? Now you get the same question. Look at your sheet. What should I write next? So the numerator, fumble. Got it? Sorry? You're right. And then what do I write next? Over. And don't go crazy with this. What's pi over 3? What's the reference angle? I actually have it over here. Okay, what's tan of 60? I'm going to cheat. What's tan of 60? I understand that. Root 3. And then what's tan of 45? Which, did I ever write that? I did. What's tan of 45? It's right here. 1. So you already have. Here's the next thing. So you said tan of pi over 3 is root 3. Anyone that puts the word tan next to that root 3, I'm taking a point off. You mathematically, syntactically still do not understand from chapter 1 on that you take a tan of an angle and it equals a ratio of sides. The word tan should not even be close to that root 3. All right, you tan an angle and you get that. Then you said minus 1. And then guess what? I don't have to ask him again. It's those same two, but in this product down here. You just have to evaluate two different things, and it goes in two different spots in this little situation. Now, I will tell you this. Next, students, it should be everyone that knows this next question, but we'll see. 8, 9, 10, 11, 12, 13, 14, 15. All right, nice. I'll clean this up a little bit. This does equal root 3 minus 1 over 1 plus just root 3. Can I cancel those root 3s? Yes or no? No! That's a 6 over 5 equals 2 error. I'm going to write this one more time. I had to write it in tutoring today. Actually, I think I had to write it with someone that was showing me something in their work. Oops, sorry. Is this true or false? 6 over 5 equals 2. True or false? That's false! 6 over 5 does not equal 2. This is proof that you cannot take a part of a sum and just cancel it with something else. This is awful bad math. So no, you can't just cross cancel. It was someone last hour there. So what you have to do is multiply top and bottom by what's called the conjugate of that. This is what I'm going to ask you. What's the conjugate of this?
1 over 1 plus root 3.
Oh, nope. Who knows what the conjugate of 1 plus root 3 is? Do you still, do you know? Did you catch yourself? There you go. It's 1 minus root 3. It's the conjugate of the bottom, but you multiply top and bottom by that because this is equal to 1. This is all equal to 1. All right, now I will tell you this, that the number one thing that is, here's what happens on this. Those that kind of have a decent idea, big yawn right there, stealing all the oxygen from the area, they get this, and then this, and then this, and then they don't know how to rationalize after that, which is not a cat problem. That's a math 2 problem. That's a math 2 situation right there. Okay, so we're going to, why the conjugate? Watch. 1 times 1 is 1. And then watch what I do here. Root 3 times negative root 3 is negative 3. Why did I not do the middle terms? What happens in the middle terms, everybody? Cancel. If you don't know that at this point, you still don't know how to FOIL. And there's nothing I can do about that at this point. Root 3 times 1 is root 3. Root 3 times negative root 3 is negative 3. So keeping yourself in order, drawing the lines, thinking about each product each time. This is not hard. It's just a little bit tedious, but I wouldn't even say it's really that tedious. And no, the numerator does not, those don't cancel the root 3s. They're both positive root 3s. So what you get in the numerator is, let's write negative 4 first, and then 2 root 3s over negative 2. And then do you do this? Yes or no, Nathan? Nate? No, it's the same reasoning, and this is what I have people do all the time on that. What you do is like cancel together. Treat this as negative 4 over negative 2, which is 2, but also 2 over negative 2, which is minus 1 root 3. All right? You're going to see all these answers. When you look in your homework, all the answers are very similar because there's not many ways we can go about this on these exact formats here. All right, next. Boom. Hopefully the ball's rolling for student number 5. You seem to always get picked. Okay, sine of 165. I need you to break that down into 2 angles. That actually would be exact values on our unit circle coordinate plane. So I'm not going to make you do it. Could be add or subtract. Add would probably be smarter, but what 2 angles added together equal 165, and they're also a 30, 60, or 45 in any particular quadrant.
135.
Boom, and that's not what we did last hour, and I like it. 135, and I'm going to stick with it, plus 30. Awesome. What's 135? Listen to this person because I'm going next. It's Jake. What's 135? But what, where? Like what specific, is it 30, 45, or 60? In what quadrant? 45 and 2, and then 30 is a 1. All right? So here we go. You got it. Because now that's what we got to do. Student number 3, Kathleen, loud and proud, speech class. All right? What, or speech team, right? Right? Still? All right, she hates it. I found that out. All right, so what's the formula say? Is it cosine, cosine, or is it sine, cosine? What does your sheet say? So sine, cosine, plus or minus, plus sines are the same. And then this is why I do sine, cosine, because now it's sine 30. I already did sine of 135, so now it's sine 30 and cosine 135. And then really the only thing that you should have to do, and I'm going to leave my work right under this, is, son of a nutcracker, 135 is in quadrant 2, and it's a 45. Kathleen, what's the sign of 135 or sign of 45? What fraction again? We had it earlier. Say that one more time. Ooh, sign of a 45. Don't think I heard it. Maybe I can't hear because you're still speaking low there. Remember 1 root 2? Right, and sine is y over r. And I heard it negative. Sine's not negative in quadrant 2, it's positive. So what's the fraction that we had earlier? I gotta go over there. It's the root what? There you are saying it. I don't know if you said that before, but I thought I heard something different. I did hear negative. It is not negative in that quadrant. All right, and then what's cosine? What's cosine of 30? Sine of 30 is a half, so what's cosine of 30? I'll go over there so I can hear you. What's cosine of 30? Nice. And it is in quadrant 1, so it is root 3 over 2 positive. And then what's sine of 30? I literally just told you that. I literally just said it a second ago. Half. And then what's cosine of 135? By the way, this is negative. I didn't write that, but cosine in quadrant 2, we should know that. Oh, negative 1 over root 2, which is negative. You said 1/2, didn't you? Negative root 2 over 2. So making you go through those again to practice your chapter 2 and chapter 3 is important. All right, and you're going to see this happens a lot. These answers are all very similar. 2 times 2 is 4. I think our last example, our first one of the day was root 2 minus root 6 over 4. Right? Okay, great. No one answered my question. Next. All right, student number 15. That seems like a repeat. Who's 15? Nice. Isn't this fun? Everyone looks so happy today on a Monday. Boom shakalaka. Another reverse analysis. First of all, is this sine, cosine, or tangent rule on your sheet? Well, don't look at the sheet. This has to be a what rule?
Tangent.
And is it sum or difference? So this is a reverse analysis again. Which one is it? The sum or the difference rule? Difference. Who am I subtracting to match this rule, match the formula, and put the parts in the right spot?
Yeah. 80 and the negative 55.
Yes. So that's number 1. By the way, just for giggles, what's 80 minus 150 or minus 55? What do you think that ends up being?
25.
Oh, it's 135.
Oh, minus negative.
Yeah, minus the negative is plus, and then you end up with 135. And then, oh no, I hit the wrong thing there, so another program's going to open. 5. Is it 1, 2, 3, 4? Last time, Jake. Okay, I got to get rid of this. I accidentally hit it. What's tan of 135? I bet you know the answer. You're fast with this stuff.
1.
Oh,
Sorry,
you're right. I knew you had to think about that for a second. Negative 1. He would be ready for calculus because he can pull those off and snap them off real quick. Tan of 45 is 1, and it's negative in quadrant 2. That's why it should be fast. We already did tan of 45 is 1. I already went over that again with you. Again, very difficult to teach people that cannot take chapter 2 and chapter 3 and remember the stuff or solidify it. That's why that consistent absence and all the other stuff just doesn't work in here, right? And then these things come back, and then the same old get in trouble mathematically. 12, and he's taking a little siesta up here. Evan, which one is this? Is this cosine, sine? Which formula does this match on your sheet?
Cosine.
And then is it sum or difference from how the formula for cosine shakes out? It is a sum. Who am I adding together to match the parts for A and B and all this other stuff?
7 pi over 9 plus 2 pi over
This is why he's taking a little siesta. He's bored because he knows all this stuff. Head of the class here. Okay, so 17. Is that another absence? There's another. Ivo. 19, another absence. 10. Who's 10? That seems like a repeat. No way, Noah. Nice. What's 7 pi over 9 plus 2 over 9? Pi. So what's 9 pi over 9? 1 pi. He never said pi. What's cosine of pi? By the way, here's your hint. That's what pi is in degrees. What's the cosine of 180, which is the same thing as cosine of pi? People do that all the time. Man, I'm starving. I think I'm going to have a second lunch today. -1. I do have to run I got my bike working, but I got to get the bike chains all rusty because I haven't rode it in 2 years, and so I might get some bike materials and then some chicken. All right. Huh? No, a bike. Come on. And then second to last but not least, what time is it? Student number 2, Jennifer. Okay, what is this? What is this match? Sine or cosine? Sine? Sum or difference? Who am I adding? What do I need to do to add these two? She's rolling here, man. This is awesome. What is the common denominator? Sucking a lot of oxygen over there, Alexis. Awesome. Who's student number 9? Nice, Adam. So she went ahead and did the heavy work here of 2 pi over 10 plus 3 pi over 10. What's 2 pi over 10 plus 3 pi over 10? What's 5 pi over 10? What's the sine of pi over 2, which is right here as a hint? Don't say 90. That's what pi over 2 is in degrees. I want the sine of pi over 2. Oh. You're grasping at things here. 1. I did write the 1. The computer betrayed me. And last but not least, everyone doing okay? That's good. 13. Who's lucky number 13? Are they absent? Is it who? It's you? Yeah. All right, here we go. Write each function as a... This is what I forgot to do last hour. I stopped short. I forgot I had this last example. By the way, this is an identity. This is called the co-function identities. Look at the top of your sheet, but don't just tell me what the answer is. But look at the top of your sheet there, right? Isn't that one of them? So we know what the answer is going to be, but we're going to put this in the formula correctly. So write each function as an expression involving functions of theta. Just means use the subtraction rule. What's the subtraction rule for cosine? Is it cosine sine or is it cosine cosine? How does it start? So now some people screw up that, wait, this is the minus rule, then these are the two angles in question. So what do I write next? Cosine of 90, then what do I write? That's theta, ma'am. Oh, you know what it is? Blah, blah. That's since chapter 1. Okay. And then what's next? Is it plus or minus? What's the formula say? Plus, and then what do I write? Tell me what to write. You be my pen here. And then what else? Okay, so this is what they're having you do, and then through this sum or difference rule, then we can come up with that co-function idea, what that comes up with. Okay, now I'll just make you finish this off. Here's 90. No, here's the coordinate for 90. I'm not going to write it, though. What's the cosine of 90? What does that become? What's the cosine of 90, which has that coordinate right there? 0. 0 times cosine of theta is 0. 0 times anything is 0. And then what's the sine of 90? 1 times sine of theta is sine of theta. 0 plus sine of theta is sine of theta. So there's the difference rule showing the co-function identity in a different way. I'm not saying it would derive it because both of them are different identities, but they coincide with each other, let's say. So that's what that means in that little section when they ask you to do this. Just a real quick thing. And then notice we're doing these quick evaluations again. Chapter 2 and 3 are back, baby. They're back with a vengeance. All right, and then there you go. There it is. See that one? Cosine of 90 minus theta is sine of theta. We just proved it through that other identity. Alrighty, I'm done.